This video shows the simulation for studying wave scattering numerically using MEP. Diffraction is slight bending of wave when it passes around an object. Diffraction depends upon the relative size of the object and wavelength, indominant when they are of the same order. A common example of diffraction is observed in CDs and DVDs where it acts as a diffraction grating, forming a rainbow-like pattern. Another example of diffraction is in sound waves as they bend around an obstacle. FDTD, finite difference time domain, is a numerical analysis technique used for computational electrodynamics and can cover a wide range of frequency because it's a time domain method.
When the size of the obstacle is much smaller than the wavelength, the reflection and scattering phenomena are not dominant. Small obstacle size results in Rayleigh scattering. A common example of it is observed in radio communication. Radio communication involves transmission of large wavelengths and obstacles which are very small in size in comparison to it. When the particle size of the obstacle is of the same order of magnitude as the wavelength, Mie scattering is observed. Scattering is most dominant in this case. An example of Mie scattering is by cloud particles, which is what makes clouds look white.
As the size of the obstacle is much larger here, we see a complete shadow with some reflections because of the metallic nature of the material. Uh, the parameters used can be seen here. The size of the lattice is 32 cross 32. Frequency and wavelength are both 1. Material used is metal. PML thickness is 1. Resolution is 10. And the size of the obstacles used are zero point 0.2 cross zero point 0.2, zero point 0.2 cross 1, and zero point 0.2 cross 5, with a distance of 10 units between the source and the obstacle. And here you can see the code with comments written after the semicolons.